Here we have an MSI Ventus 3090 video card that came in for repair. That's how the card looks like. And the customer was actually very brief. Let me show you. The customer wrote, referral, YouTube, description, doesn't power on, possible short. Brief and straight to the point. I love it. Let's take a look at the card. And we'll take it one step at a time. The first thing I do is I inspect for a 12-volt short. 0.416 diode mode. 0.43 voltage drop in diode mode, so we do not have a short on our 12-volt lines. And if we move down a bit, measure our 5 volts. And look at this. We have a short circuit on our 5-volt line. Wow. 20 seconds in, and we discovered that we have a short circuit on our 5-volt line. If we do not have 5 volts, then we're not going to have 1.8 volts. We don't have 1.8, we're not going to have core, and the video card is not going to work. We need 5 volts for everything under it to work. So before we do anything on the card, or maybe we can do a quick visual inspection. It will take us a minute. Maybe we have a ripped component, a blown component, discoloration, liquid damage, corrosion. It does not hurt to do visual inspection, especially in this area here. PCIe connector is good, no cracks. Two seconds in, and we already know that we have a 5-volt short. That's amazing. Usually 2 seconds in, we know that we have a 12-volt short. But today, it's different. It doesn't matter, 12 volts or 5 volts. We're going to find the bad guy. No doubt. We are the kings of finding shorts. No problem. 90% of electronics fail because of short circuit. And I do not see anything obvious. It's not liquid damage. You see this on many video cards. The card looks wet because of the thermal pads. But that's not liquid damage. Oh, look at this. Look at this. Is that a crack? Yeah, it's a crack. And it's right behind our 5-volt. Actually, no. It's on back of the board on the other side. This guy is cracked. But this should not cause a short. It's an inductor. Meter and diode mode, and we're going to measure to ground. And we have a short here as well. Look, one side is shortened to ground, and the other side is reading 2.2 voltage drop. So we know the inductor is broken from the inside. It's not making a continuous path. We know the inductor is blown because of a short circuit, because one side is shortened to ground. This side right here. Wow. You know what? Maybe we can start by removing this inductor. And look at this component. It's the last component on the board. I almost thought that we do not have anything wrong with the board. I wanted to flip the card, and I noticed this. We are at the end of the card. Look at this. Why is it the last thing that you check is where the fault is? I was going to stop right here. And the last component on the board is broken. Nice. We're gonna have to remove this component anyway, but we have to keep in mind that we have a short circuit right here. And we also have a short circuit on our 5-volt line. I do not know if this has to do anything with 5 volts. I do not have schematics on hand. And I do not know if one exists for this card. And when I say schematics, I mean schematics and board view diagram, not just schematics. You cannot do anything with just schematics. Inductor is out. And we should still have a short. And we do. Let's go back to our 5-volt area. And how about we measure the chip right next to the coil? I know that chip. I've worked with that chip before. Many times. Pin number 1 is on the bottom. Pin number 2 is 12 volts. So we should read 12 volts on pin number 2. Pin number 3 is 5 volts. Pin number 4 is ground. Pin number 5, what is pin number 5? P good. Pin number 6, if I remember correctly, is enable, 5-volt enable. Pin number 7 is VCC. We should read 5 volts here. And pin number 8 is feedback. I just want to quickly measure in diode mode. The only short we should have on this chip is pin number 4. This guy right here. 12 volts. We do not have a short. We have 0.4 voltage drop, and that's good. We do not have a 12 volt short. We already measured on the top. And we do not have a short on 12 volts. 5 volts, we have a short circuit, of course. Ground, we have a short. P good, we have a short, a dead short. Our enable, we do not have a short on enable. 0.5 voltage drop. VCC, 5 volts VCC, we have a short. And feedback, we have 0.552. So what is the problem? We have shorts everywhere. I honestly believe the problem is the chip. I do have a donor. We can grab that chip from a donor and we'll solder that chip. It will only take a minute, and then we will see if by removing the chip we are able to get rid of the short rather than investigate and spend a lot more time. I do have a donor right here, and this is the 08 equals IC. Let me do quick measurements on this donor board. Meter in diode mode. So 12 volts, we do not have a short. 5V, we don't have a short. Ground, we do. No short, no short, no short, and no short. That's how a normal chip should behave. Only one ground, pin number 4. If you did not know that, now you do. Okay, that chip is out. Let's put it on the side. We did not burn that connector. And so far, so good. Now we're gonna check for a short again. Do we still have a short? That's the question. Meter in diode mode. And we're gonna check right here. And look at this. We have 0.29 voltage drop. The reading is going up, 0.3. Awesome. Awesome. We do not have a short anymore. Let me measure the pins on the chip. So the only short we should have is pin number 4. Pin number 3, do we have a short? And no. Wow. 0.34. Do we have a short here? We do not. Do we have a short here? We do not. Do we have a short here? We do not. Do we have a short here? We do not. So that's the problem. The chip is the problem. Hopefully nothing else is wrong with the card. By restoring 5 volts, we're gonna restore 1.8 volts. Core will work, and the card should work. How long did it take? How long did it take to figure out that we had a short circuit, and how long did it take to figure out that that chip is the problem? We took an educated guess, and we got it. Rather than looking for schematics, looking for a board view, which is nice to have, but you have to work smart. It only took me a minute to remove that chip. If that chip was not the problem, then I'll put it back. It only took a minute. Anti-glare light, because I cannot see anything with all that glare and reflections. And the magic of anti-glare. Amazing. Now I'm using the NF.mini pen, and that board is thick, so we're gonna need the help of hot air. And maybe add more solder. Alaikum assalam. All right, so let's grab this chip from the donor. And we are on our way to a working card. Or maybe I'm being too optimistic. And we have to make sure that pin number 1 is on the top left on this donor. Same orientation. And yes. I'm using the NorthridgeFix brush, Kimtech wipes, and 99% isopropyl. You can purchase Kimtech wipes and the brush off our site, along with all the tools that we use on our bench for the most part, including this amazing microscope, articulating arm, hot air station, soldering station, tweezers, original Amtech Flux like the one that we used here, thermal cameras, power supply, everything. One-stop shop. Just log into NorthridgeFix.com, click on shop, at the cart, checkout, pay. And we almost always ship out same day. And for all of you who have ordered from us before, you know how fast we ship. So now what I want to do before we power on this card is I want to check for a short again. 12 volts. 12 volts. 5. Ground. No short, no short, no short, and no short. We got it. We got it. Let's power the card on. Everything is connected properly. We have 6 beeps. Why? Now, one thing I forgot is the coil that we removed. I did not put that coil back, and I did not check if we still have a short circuit on that coil. Big mistake. I totally forgot about the coil. I got so excited with the short being gone on that 5-volt rail, I forgot about the coil. What can you do? That's what excitement does to people. So let's go under the microscope. Do we still have a short circuit? And we do. We still have a short. So for this one here, what I'm going to do is inject voltage, and we're going to monitor the board under a thermal camera and see what gets hot. That board want to play games. We are the kings of playing games. Oh, the core is getting hot. I'm going to inject voltage and flip the board at the same time. And I do not see it. Yeah, core. Looks like it's getting hot, but nothing else on the board. But let me check on that donor board. What readings should we have on this coil? Just curious. We should have a 0.5 voltage drop reading and not a short. I mean, it's obvious. We're going to have to leave this until tomorrow anyway. It's already end of the day. For now, we're going to leave it until part 2. I hope you enjoyed the video. Any information that you have, leave it down in the comments. Schematics, board view diagram, send it over to me, and I will share it in part 2. And I'll see you again in part 2 or in the next video.